And now we have Ms. Chuka presenting. Take it, Ms. Chuka. Thank you.
Hello, everyone. First, I wanted to ask, we're going to be separating into 2 rooms, and you haven't done that, right, Peter?
Yes, ma'am. We haven't split.
Okay. So if you are a 1324 student or an NCBM 0324 student, you will be clicking on the link that that was just sent to you. It's the tinyurl.com EPCC TV E2. And that's going to take you to the 1324 room with Mr. Isasi. And then for the 1314 students, you will just remain in this room, and we will start here in a second. So everybody that needs to go to 1324, please click on the link that was just put in the chat. If you're a 1314 student, you're going to stay in this room. So we'll give you about a few seconds just to see who needs to be moved. Ms. Bolden, you have a question? Ms. Bolden, you have a question?
Hello, can you hear me?
Yes, I can hear you now.
I was just looking for the URL so I can click on a 1324. I found it though. Thank you.
You found it? Okay, great. Okay, so today for the 1314 class, we're going to be covering synthetic division and complex numbers. And our main focus is going to be to understand the process of synthetic division so that in next week's sessions, you can apply it to help us find the zeros. At any time, if you have any questions, please feel free to put it in the chat or raise your hand and we'll call on you. And then we're going to have some fun with synthetic division and complex numbers. Okay, so we've been talking about X-intercepts and zeros in the past sessions or in your classes. And I wanted to just highlight here that a zero, which I have circled one of them here at x equals 2, is where the graph crosses the x-axis. And so if x equals 2 is a 0, then we can say that x minus 2 is going to be a factor. So the word 0 and factor are going to be essential to this section 2.3 and 2.5. Okay. So synthetic division in this section 2.3, you also talked about long division. And so synthetic division is just a shortcut for long division. And you can use it whenever you have a divisor that is in this form here, where you have x minus c. Okay, so to divide a polynomial by x minus k, we're going to follow the process below. So the first thing you want to make sure is that your dividend, which is this here that I highlighted in a box, is in order from largest to smallest as far as the degree goes. So notice here the 3, we have a power of 3, a power of 2, and then a power of 1, and then your constant. So you want to make sure that you arrange them in order. Then we're going to, step 2, we're going to identify if you have a missing term, then you want to use a 0. So for example, if you didn't have an x term listed here, then we would just fill it in with a 0. And then the third thing we're going to do is we want to identify what k is. And k can be found by looking at the divisor, what we call a divisor. So here we have x minus k. So what we're going to use here is going to be that k. And then we draw this little L shape here. And on the top, we're going to list the coefficients. which are the numbers that are in front of all the x variables. Okay, the next step we want to do is we want to bring down the a. So we're just going to bring down the a straight down. And after we do that, then we're going to multiply x times a. I'm sorry, we're going to multiply k times a. And whatever we get there, we're going to place in the bottom of b. So we're going to place it right here. Once we do that, then we're going to add b plus k times a. And whatever answer we get, we're going to just put it straight down here below that. And then the process is going to continue. And you'll see it right now with numbers, exactly what we mean. So the next step here is we would continue the process, and it would fill in what goes under C and what goes under D. Okay. The next slide is just going to show you all the steps written there. So whenever before I do that, the last number that you get here is called your remainder. And the numbers before the remainder are going to make up your quotient. Okay. And the quotient is what we're going to be really after to help us find all the zeros. The next two slides just show you all the steps. And the reason we wrote them there is just so that when you get a hold of this PowerPoint, you can go over the steps that I mentioned here. But these are the 3 steps that I just talked about right now. And then you have the other steps here. But I'm going to go over all these steps using an example. Okay. So before we start this example, if you're just joining us, if you are in 1324, make sure that you click the link and go to the other session. 1314 students will stay here. Thank you, Peter, for putting the link. Okay, so let's look at an example. So here we have divide x squared plus 5x plus 6 by x minus 1. So the first thing you want to make sure is you want to make sure that your polynomial is in order from largest to smallest as far as the degree goes. So here we have x squared, then we have an x to the 1 power, and then our constant. So this is in order. Okay, so that's a good thing. We don't need to do anything there. And then we need to identify what k is. Okay, so remember k is going to be what we're subtracting from x. Okay, so here we're going to have that k is going to be 1. So we write down the 1 on the left side. Then we're going to list all the coefficients. Okay, so the coefficient of x squared is going to be 1. The coefficient of 5 is going to be, the coefficient of x is going to be 5. So I write it down here. And then my constant is 6. So the next thing we want to do is bring down the 1. So we just bring it straight down. And then the next step is to multiply 1 times 1. And whatever answer you get, we're going to place below the 5. So here we get 1 times 1 is 1. So we get 5. Then the next step is to add these two numbers. 5 plus 1 will give me a 6. And then we start the process again. So we're going to multiply 1 times 6, which is going to be 6. And I'm going to place my answer up here. And now we're going to add them. So 6 plus 6 is going to be 12. Okay, so that is the process of the synthetic division. But now we have to understand what all these numbers mean. And so in the next slide, the 12, which is your last number, that's going to be your remainder. The remainder is very important here. If you have a remainder of 0, then that's going to be something that should make you super happy. Okay, if you get remainder of 0, that's going to be the best thing that should happen. If you don't, it's okay. But 0 is always going to be a great thing, and I'll explain why it's going to be good. Okay, the other numbers mean these top 3 numbers. Those are what make up the dividend, right? That's just our problem right here. Those are the coefficients. And the this 1 is coming from our what we call the divisor, okay? So the divisor is what we're dividing by. Now the bottom numbers before the remainder, the 1 and the 6 here, is what we will call the quotient. And the quotient is going to be crucial in helping us solve for the other x-intercepts and zeros. When you write the quotient, you want to remember that you want to write the quotient with 1 degree less than the dividend. So the dividend here, the highest power was a 2. So when you write your quotient, it's going to be 1 less. And your answer should always be written as the quotient. So here, the 1, we would have 1x. So the 1 is really here, but we don't write the 1, right? But you could. So we have 1x plus 6. That's our quotient. And then the remainder was 12 divided by the divisor, okay? And so that is the process. And so we'll do a couple of more examples with different situations. And I'm going to ask you some questions here as well. So here we have this polynomial, and we want to divide by x minus 8. So first we identify k. So k is going to be 8, okay? And then we list the coefficients. So the coefficients are going to be 4, and you want to make sure that your exponents are in order. So we have 3, 2, 1, and the constant. So those are good to go. So my coefficients are 4, 36, 36, and net constant negative 32. So the next step is bring down the 4, and then we're going to multiply 8 times 4, and that gives me a 32. And then we add 36 plus 32 is 68. And then we start the process again. So I'm going to multiply 8 times what number? And you can put it in the chat, or you can just say it if you like. 68. Yes. So I multiply 8 times 68, and I get 544. So that number goes below the 36. So now I'm going to add 544 plus 36, and that gives me 580. And then I continue the process. So now it's 8 times 580, which is 4,640, plus negative 32 becomes 4,608. So what is my remainder in this example? So our remainder is going to be 4,608, right? Good job. So to write my answer, I'm going to write my quotient. Okay, so how do I do this? So I start with the 4 here. And then I know it's going to have an x, but the degree, you need to look at your dividend. The highest power was a 3. So you start with 1 less. So now we're going to be at a 2. Then we bring down the 68. So we're going to have plus 68, and then it's going to be x. And then bring down the 580 plus 580 is our constant. And then we have the remainder, and that's divided by the divisor. Okay. Any questions on that one? Okay, so example number 2. Use synthetic division to divide 3x cubed minus 6x plus 21x squared minus 42. So our first step, or let me ask you, you tell me if I did this correct. So my C is going to be 7. You guys tell me if I did it correct. I'm going to write 2, and then you guys can tell me which one it is. Okay. So it's A, or I have B, or C. Okay, so which one is correct? Okay, so let's check. So the first step is we have to make sure that our dividend is in the right order. Okay, And what I mean by that, we have 3x cubed. The next thing should have been 21x squared. Okay, so the first thing you want to do is rewrite it. So I rewrote it as 3x cubed plus 21x squared minus 6x minus 42. And then we have divided by x plus 7. Now we need to identify k from x minus k. So notice that we have x plus 7. Well, I can rewrite x plus 7 as x minus negative 7. So in that case, what will k be if I have it written as x minus negative 7? So from here, we can see that k is actually going to be a negative 7. Okay. So now we put in the coefficients. 3, 21, negative 6, negative 42. Bring down the 3. Nice. Negative 7 times 3 is negative 21. If we add the 21, and the negative 21 would give us a 0. And then we start the process again. Negative 7 times 0 gives me a 0. And then I'm going to add negative 6 plus 0 gives me a negative 6. And then I multiply again. Negative 7 times negative 6 gives me a positive 42. So if I add, I get a 0. So what did I say about the 0? Should we be excited about a 0? Yes, right? And the reason we have to be excited is because that's going to tell you something very important. And I'm just going to briefly tell you what that is here. I have a different slide to go over it, but I'll just give you an example. Since you got a 0 here, what that tells you is that this number at x equals negative 7 is a 0. So here's negative 7. And so that's going to be a 0. Okay. Why is that important? In section 2.5, your goal is going to be to find all these zeros. And that's where the graph is going to cross, for example. So yes, it's going to be, you're going to be smiling every time you get a 0 down there. Okay, so let's continue. Give me a second. Austin, close the door, please. Okay, so we go to the next thing. So my answer here is going to be, my quotient is 3x squared. Again, I start with the 2 since we had a cube, plus 0x minus 6. My remainder is 0 divided by x plus 7. When you enter your answers on WebAssign, you don't want to enter 0 divided by x plus 7 because that's not simplified. So 0 divided by x plus 7 is really 0. So if I simplify this, then I really just have 3x squared minus 6 because 0 times x is also 0. Great. So let's try another one with a different situation. So here, if I rewrite my polynomial, I have x cubed minus 3x squared, but I have no x. Since I don't have an x, I need to include a placeholder. So I'm going to put here 0 times x. And then I have a 6, and then divided by x minus 5. Okay, so it's important to put that placeholder, or else your answer will be incorrect. Okay, so my c is going to be 5, or my k is going to be 5. And my coefficients will be 1, negative 3, 0, and 6. Bring down the 1. 5 times 1 is 5. If we add, we get a 2. And then we multiply again. 5 times 2 is 10. And then we add 10 plus 0 is 10. And 5 times 10 is 50. And then we add 56. Okay. So here we didn't get a 0. Okay. So if you were looking at a graph, what that means, and the reason we're going to be sad not to have a 0 is because at x equals 5, right here, that just means that the graph does not cross at x equals 5. Okay. The graph might be somewhere else, but it does not cross at that point. Okay, so my answer here I have a x cubed, so my 1 is going to be x squared plus 2x plus 10 plus my remainder of 56 divided by my divisor x minus 5. Any questions on example 3? Okay. So again, the goal for this week in your classes is to understand how synthetic division works. That way you can use it to find the zeros in section 2.5. Another theorem that appears in section 2.3, I believe, is something called the remainder theorem. And it says if a polynomial f of x is divided by x minus k, then the remainder is going to be r is equal to f of k. And so we're going to see right now what that means. Okay. So it says use the remainder theorem and synthetic division to find each function value. Okay. So first I'm going to use synthetic division. So here, given f of 1, we know that x is going to be equal to 1. Okay. So remember, the number inside is your x value. That's why I put x is equal to 1. So to find k, we subtract the 1 on both sides. So if from x equals 1, the factor, so if I have x equals 1, my factor is going to be, subtract the 1 on this side. This is going to be your factor. Okay, and so from you can get your k. So my k is going to be 1. And shortcuts would be, if you see it here, they're telling you that x is equal to 1, so that is the number that goes here. Okay, but the reason we can say that is because this reason right here. My coefficients are 2. I have no x squared, so I need a 0. Then I have a negative 7 and a positive 2. So I brought down the 2. 1 times 2 is 2, so I place that up here. 2 plus 0 is 2. 1 times 2 is 2. Negative 7 plus 2 is negative 5. Negative 5 times 1 is negative 5. Plus 2 gives me negative 3. So my remainder here is going to be negative 3. Okay. The remainder is negative 3. So what that tells us is that the value of f of 1 is equal to negative 3. And so this answer here is negative 3. In the first sections, we did it this way, where we plugged in the 1 for every x that we see. So here I plug in 1, and I get 1 cubed is 1. Negative 7 times 1 is negative 7 plus 2. 2 times 1 is 2. Minus 7 plus 2 equals negative 3. Notice that the remainder here is the same answer we get when we plug in 1 for every x that we see. Okay, so that theorem is just saying that if you plug in this value, your remainder will be that the answer you get is going to be your remainder. So on this one for letter B, if we plug in the negative 2 and I apply the synthetic division, I bring down the 2. Negative 2 times 2 is negative 4. 0 is negative 4. Times 2 is negative positive 8. Plus negative 7 is a 1. Times negative 2 gives me negative 2. I have a 0, so that's wonderful. So what does that mean? For x equals negative 2, my answer, or my remainder in this case, is 0. And so what that tells me is that x equals negative 2 is a 0 of this polynomial. In other words, it's an x-intercept. And what I mean by that, let me go back. What I mean by it being a 0, it just means that your graph at x equals negative 2, it's going to cross at that point. If we plug in the numbers, and you know what, I didn't plug it in here. So we can just, let me just work it out here. Well, I think it's right, but it's just, this should have been a negative 2. So let's check our work. So we plug in 2 times negative 2 cubed minus 7 times negative 2 plus 2. Negative 2 cubed would be a negative 8 times 2. Negative 7 times negative 2 is 14. And then we get a plus 2. So the work is okay. Just make sure that you know that there should have been a negative 2 here. 2 times negative 8 is negative 16. Plus 14 plus 2 is going to give me 0. Okay, so again, you can do it both ways. So how does synthetic division help us solve equations, which is the main point of section 2.5, is how do we solve these equations? Okay, so I'll give you an example. Find the zeros for the given function. So in section 2.5, you'll be learning some other theorems to help you get started. And so for now, I'm just going to go ahead and let me just write something here. Find the zeros of the given function, given that x equals, I forgot what I had. Give me a second. X equals negative 2. Okay. So find the zeros given that x equals negative 2 is a 0. Okay, so you're going to see problems that say this. Since they tell you that x equals negative 2 is a 0, then you can apply synthetic division. And so we take that x equals negative 2, and that's going to be our k. Then we take our coefficients 2. There's no x squared, so 0, negative 7, and then 2. Bring down the 2, so we get negative 2 times 2 is negative 4. Plus 0 gives me negative 4 times 2 is negative 8. Plus negative 7 is 1, and then we end up with a remainder 0. Since they tell you that x equals 2 is a 0, then that means that if you get something in the remainder that is not a 0, then that means you did something wrong, okay? In this case, we did get 0, so we're good to go. So how does that help us? Well, this is how it's going to help us. Since x equals negative 2 is a 0 of the function, they told us that, and we did get 0. We can use the quotient, okay? So my quotient, remember, we take the 2, and this is going to be 1 degree less. So if we had degree of 3, now we're going to have degree of 2. So we have 2x squared minus 4x plus 1 equals 0. The good thing about this is you take that quotient, and now notice that the degree is a 2, which means that it's quadratic. So everything you learn in 2.1 on how to solve quadratics, you can apply it here. So a quadratic function is a lot easier to solve for x than a cubic function or something that is higher than degree of 3. Now that we have a quadratic here, you have options, right? You can factor. You can use the square root property if it's possible. Factoring if it's possible, right? Or you can stick with the one thing that works no matter what. So the quadratic formula works for everything. You can use a quadratic formula. For me, I like to try to factor, and I give myself less than a minute. And if I can't get the factors, then I move on to quadratic formula. And so for this problem, to the right over here, it does factor. So it factors as 2x minus 1 times 2x minus 1 is equal to 0, okay? So now I can set each factor equal to 0. So 2x minus 1 is equal to 0, and 2x minus 1 is equal to 0. Solve for x, so I get x equals a half and x equals a half, okay? So the zeros for this function, I'm going to list them here. We get x is equal to a half, x is equal to a half, and what's my other 0? What's the third 0 that we have here on this page? Negative 2, correct. Because that was given to us, right? And also because we got remainder of 0. So these are our 3 zeros. Now, you might be asking yourself, well, I mean, do we really have 3 or do we have 2? Because x equals a half is the same as x equals a half. And here, if it's repeated, it's okay to be repeated. I have 3 zeros, and notice your degree was, so you should have 3 zeros at the end of doing this, okay? The reason it's repeated has a lot to do with, and you're gonna learn this in section 2.5 also. Here's -2, and let's put a half, I guess, here. That's gonna tell you if the graph is going to cross or if it's gonna touch, okay? And so I'm not gonna get into details on this yet because that's for next week. But in this case, for at x equals a half, the graph is either gonna touch this way or it's gonna touch this way. Okay, and we'll learn that in the next section, and you'll see why if it touches going that way or which direction. And then for x equals -2, the graph is gonna cross. But we'll talk about that next week. The important thing here is getting the zeros for this section. Okay, so I'll take a second. Any questions on synthetic division? Okay, so when the mathematicians were working on these number systems, they ran into a question that looks something like this, probably. X squared plus 1 equals 0. And their goal was to solve for x. But when you solve for x, notice what happens. You have negative, we subtract 1 on both sides. So we get x squared equals -1. They took the square root. But then here we get x is equal to the square root of -1. Since we have a negative here, that means that we have no real solution. Okay, so what the group of mathematicians did back then is they said, okay, we really need something to help us continue exploring this. And so they develop a whole new number system, and they call it the complex numbers. And so that's what we're going to look at right now. When you have no real solution, what that means is that the graph will never cross this x-axis. Okay, so there's no, the graph will never cross it. So it's either up here or it's down here, but it's never going to cross the x-axis. That's what it means if you have no real solution. So they came up with this imaginary unit, which is called I, and they defined it as I is equal to the square root of -1, where I squared is equal to -1. So you want to remember this right here, because we're going to be using that quite a bit. And then the standard form is A plus BI, where A is the real part and BI is the imaginary part. Okay, and so that's what it says here in the definition. I'm not going to read it, but that's what it's saying there. So operations, so we have to be able to add, multiply, subtract, and divide the complex numbers. So when you're going to take the sum and you have an imaginary number plus another imaginary number, you add the real parts A and C, you add them together, and then you add B plus D, and then you keep the I, okay? And the same for subtraction. You subtract the real parts, A minus C, plus B minus D. Or you can just use order, the rules of order of operations will apply here. Okay, and I'm going to show you both ways. So we're going to work these 3 problems out. So the first one says add these 2 complex numbers. So I put the definition up here, that way you can see it. So the first one I have 3 plus I plus 6 plus 5I. And so what we're going to do is we're going to take the A's, which is the real parts, and we're going to add those together. And then we're going to take the B, which is the number in front of the I. In this case, B has a 1, and then the 5. Okay, and we're going to put those together. So 3 plus 6 is 9, and 1 plus 5 is 6. So my answer here would be 9 plus 6I. Or method 2 is actually what I use. I find it easier than having to memorize this definition, okay? And so you can use whichever method you prefer, but I just treat it as finding like terms. So here I have 3 plus I plus 6 plus 5I. So all I do is I drop the parentheses, right? So I have 3 plus I plus 6 plus 5I. So then I decide I'm going to add common terms. So 3 and 6 are common. So 6 plus 3 is 9. And then I plus 5I are common. So it's like if you had x plus 5x. And then we end up with 9 plus 6I. Any questions on that one? Okay, let's go to the next one. So I'll give you a second to try this one. 3 minus I minus 2 minus I. So I'll give you about a minute to work it out, and then we'll see if you got the right answer when I work it out. Yes, so Ruben says, don't forget to answer on WebAssign in standard form, real plus imaginary. So you always want to make sure that your answer is in this form, A plus BI. Okay, so let's see if you ended up with the same answer here. So if we're using method 1, then we would have 3 minus 2 plus negative 1 minus negative 1. And then, so 3 minus 2 is 1, negative 1 minus negative 1I is 1. So my answer is 1 here. Now, if you enter this on WebAssign, it's kind of weird sometimes because, like on my exams, I always want it to be entered as Ruben said, imaginary, right? So 1 plus 0I. But if you enter 1 on WebAssign, it'll more than likely count it right because of the 0 times I is just going to be 0. But if it does count it wrong, then enter it as 1 plus 0 times I. If method 2, if you drop the parentheses here, you want to make sure that you distribute the negative before you drop the parentheses. So here we have 3 minus I, and then negative times 2 is negative 2, and negative times negative is positive I. Then you combine like terms. 3 plus negative 2 is a 1, and negative I plus I is 0. Okay, any questions on that? Okay, so let's look at the next one. We have perform the operation and write the result in standard form. Okay. So the first thing you want to do is take care of these negatives. We don't want these in here because we really can't do anything with them in there. So we're gonna take care of those first. So I just wrote down the problem. So then I have negative 3 plus negative 1 times 8. Okay, so let me just write it really big here. So this negative 8, all I did is I rewrote it as negative 1 times 8 because that's going to give me the same thing. And then we do the same for negative 56. We write it as negative 1 times 56. Okay, so that's what I have here, negative 1 times 8 and negative 1 times 56. Then you want to remember, down here I put, recall that I squared, by definition, in this complex number system is equal to -1. So anywhere I see that -1 in the square root, I'm going to replace it with an I squared. So here I have -1. So I'm going to put I squared. And let me see. And -3 plus a +5 is a 2. So this is where my 2 came from. Okay, so let me just circle it so you can see. -3 plus 5 gave me this +2. Okay, so -1 is I squared times 8. And -1, I replaced it with I squared times 56. So now the square root of I squared is just going to be equal to I. Okay. Why? I can tell you why here. Let me tell you why. In case you're wondering, the square root sign is the same as an exponent of a half. So I squared, if we multiply 2 times a half, we get 2/2, which is equal to I. People just say that they cancel, but it really doesn't cancel. It simplifies to I. But I'm going to leave it as if you remember by saying that it cancels, then that's fine. So I squared is going to come out as I, and I squared is going to come out as I here. Okay. Any questions? Okay, now we have to worry about the square roots. The square roots have to be simplified. So for 8, I wrote 4 times 2. Notice that 4 is a perfect square and 2 is not. And then 56, I wrote 4 times 14. And so the reason we do that is the 4 can now come out as a 2. So the square root of 4 is a 2. Let me use the pointer here. So the square root of 4 comes out as a 2, and I already have the I. And then the square root of 4 comes out as a 2, and I already have the I here as well. The 14 and the 2 in the square root, those cannot come out anymore because they're not perfect. Now this is not in standard form, right? Because our standard form, recall, is A plus BI. So we need to rewrite this. Notice now that for these two terms here, these two terms, they both have an I, so I can factor out the I. So if I bring out this I in the front, then I'm going to be left with 2 plus I times 2 times square root of 2 minus 2 times square root of 14. I cannot add or subtract these because the radicand is not the same. What I mean by radicand is the number inside of the square root is not the same. In order for me to be able to add 2 radicals, I would have to have the same radicand. So like here I would have 3 plus 1 would be a 4 square root of 2. But since these are different, then we cannot add them together. Okay, and we have quite a few more here as well. So what if we multiply? So here we're going to be, let me go back here. We're going to just multiply, and some of you know it as FOIL. So 1 times 8, and then 1 times -7, I times 8, and I times -7i. So when we do that, we get 1 times 8 is 8, 1 times -7 is -7, I times 8 is 8i, and I times -7 is -7i squared. Okay. So our next step is to combine like terms. But first, notice that I squared is equal to -1. So here, instead of I squared, I can replace it with a -1. Okay, so I have 8 plus -7i plus 8i gives me the I. And -7 times -1 is a +7. And 8 plus 7 is 15 plus I. It is in standard form, so I'm good to go. Okay, was that the same one? No. Okay, so the next one, if we're multiplying 17i times 1 minus 7i, first we're going to distribute 17i into the parentheses. So we have 17i times 1 and 17i times negative 7i. So we end up with 17i minus 119i squared. Next, we're going to replace I squared with a negative 1. So here's my I squared. I replace it with negative 1. So I get 17i plus 119. Then we simplify. And so in this case, I can't combine any like terms, but I wrote it as 119 plus 17i in standard form. Any questions on that one? Okay. So that's in standard form. Let's go to the next problem. All right. So here we have negative square root of negative 75 plus square root of negative 12. So remember earlier I said, let's get rid of these negatives in the square roots. And we can do that by rewriting it as negative 1 times 75 and negative 1 times 12. Once I have these negatives in the square root, I can replace them with I squared. So I'm going to have I squared times 75 and I squared times 12. The I squared is going to come out as an I. So I get I square root of 75 plus I square root of 12. Okay. So right now I can't add these together because the radicands are not the same. But more importantly, 75, square root of 75 and square root of 12 are not simplified. So we need to simplify those. So for 75, I can write it as 25 times 3. The good thing is that since we want them to be the same, 25 is perfect, right? But the 3 is going to stay in the square root. So you can ask yourself, can I rewrite 12 so that it still has a 3? And we can, right? So 4 times 3 is also 12. So now the square root of 25 comes out as 5. And then you have your I. The 3 stays inside. And then the square root of 4 comes out as a 2. And the 3 stays inside. So can I add I square root of 3 plus 2i square root of 3? So can we add those? Do they have the same radicand? They do, right? And again, by radicand, I mean the number inside. So notice here it has a 3 and it has a 3. So to add, we just add the coefficients together. So we're going to have 5i plus 2i gives me 7i square root of 3. And then last, you want to write in standard form. So I don't have a real part, so I can just use 0. 0 plus 7i square root of 3. Okay, so now let's talk about this problem again. In chapter 2, it goes back to solving these equations, right? So x squared minus 2x plus 2 equal to 0. And it says to solve. What does it mean to solve? Let me just write here. So when you see a problem that says solve, find the zeros, find the roots, or find the x-intercepts. All they're asking us to do is one, these all mean the same thing, okay? It means what are these x-intercepts? What are these points on the graph what are the points where the graph crosses the x-axis? So in order to solve for that, you have to let y equals 0, which I did here, okay? So it says use the quadratic formula to solve this equation. So I wrote the quadratic formula in here, x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Identify your ABC. So a is the number in front of x squared, which is 1. B is the number in front of x, which is -2. And then c is 2. And so we did a couple of these last week. We next substitute those values. So we have minus -2 plus or minus -2 squared minus 4 times 1 times 2 divided by 2 times 1. Then we simplify. So we end up with negative is a +2, plus or minus the square root of -2 squared is 4. 4 times 1 times 2 is 8 divided by 2. 4 minus 8 is going to be -4. And so already here, since you have a negative, you know that there's no real solution. So your graph is going to be either above the x-axis or below the x-axis. So let's simplify some more. So I'm going to go ahead, instead of writing a -4, I'm going to write it as -1 times 4. So the -1 I can replace with I squared. And so that comes out as an I. And then we have the 4. Square root of 4 is going to be a 2. So I get 2i here. Okay. So how do I simplify this? So we have 2 plus or minus 2i divided by 2. That just means the same as 2 divided by 2 and 2i divided by 2. So if you write it like this, you can see it a little bit more clear. 2 divided by 2 is 1. 2 divided by 2 is 1, and then you have the I. So what does 1 plus or minus I mean? One solution is x equals 1 plus I, and the other solution is x equals 1 minus I. Okay, so again, hopefully you can join us next week, because we're going to talk about, well, how do we find all these zeros that we've been talking about. And in my opinion, I believe from what I see and hear from my students, section 2.5 is the one that's a little bit harder than the other sections. And so next week we're going to focus on that section. And believe it or not, guys, we went through, it's kind of funny because this document says it has 115 pages. But the reason it's so long is because for any little animation, I just made it into a separate page because I wanted to make sure that I could see the chat today. So anyways, I will send this to you. Please make sure that you sign in. I will send this to your instructors if you're getting tutoring credit. So use this form here. And any information that you put in there, also put your email link, and I can send you this PowerPoint along with the recorded version of it. And if you have any questions, I'm going to put my email here. So maybe if you want to send me a message and say, can you go over this type of problem next week, then I will go ahead and make sure that we get those questions answered as well. And then if you have questions right now, maybe you have a few minutes and you want to just, maybe you're working on your assignment on WebAssign. We do have tutors here that can stay past 4 and work with you on a one-to-one basis. And so our tutors are ready to help you with any questions that you might have. Now, is there any questions regarding any of the problems that we did today? Okay, so I hope that if you were working on these sections, I hope that if you were stuck on any of the problems, I hope that this helped you to see some similar examples. And again, please feel free to let us know if you have any questions.
Thank you, Ms. Chuka, for today's presentation. Thank you, everyone, for coming and especially for participating. We hope to see you again next week. And remember, we are recording these sessions, and I'm going to stop the recording right now, but right after, I'm going to place the link in chat for the previously recorded sessions.